please take a moment and celebrate David's joining the stage. Come on aboard.
Thank you. Thank you very much. Good afternoon. I have the most difficult time, as you know. Just after lunch, I hope you had a good time, and we have a very nice weather, which is very usual, obviously, in Cannes. So I'm originally from Cannes, so I'm not going to do this presentation to you in English, but if you want, I can do it in French. No, the other way. So what I would like to talk to you about is actually opening your eyes to what's going on in the universe of infrastructure that is supporting the AI workflows, the workloads, the use that's happening every day as we take our phone, as we take our computer, and launch a query and get a response. It's kind of magical, and that magic has been in works for years and years of layer after layer of software and hardware and power engineering. I think we arrived to a point which I believe is very critical. And I would like to start our session with, first of all, celebrating these 3 years that we have seen the birth of LLMs, the Gen AI. But as you know, AI has been in the works for far more than the last 3 years. It's only about, in 3 years ago that things have coalesced to become useful, what I call the general public. So 3 years it's been, I would say, surprise after surprise in terms of usefulness of what we collect from our queries. And if you have been using, like I do, this technology, you've seen a massive progress in quality, in speed, in accuracy, in richness, in modality. And all of that is a very interesting thing because it's helping answering very important questions. What has happened over the last 12 months? How much energy we've consumed more than last year? How much more usage there is in terms of everyday use of AI? How many more devices have been connected to the network, to the grid? That is something that we depend on as we take our phones and use them. And last but not least, how many users are now using AI over the last 12 months? Let's look at these numbers together. So we have now, and these numbers are not mine, they are coming from different sources which are all being checked. We now have over 800 million weekly users of AI. So in other words, 10% of the world's population. That's interesting because that means that there is a significant, huge number of people who have not yet to use AI as it comes to their day-to-day needs. It's 100% growth nevertheless, but it just tells you what's coming ahead. In terms of session, so this is what I call the usage, not the users, we are now at 14 minutes per session. So in other words, 133% more time we spend using AI than we did a year ago. And what does it mean? That means that we are not just sending one query or one prompt, but we are following through, and that keeps going on and on and on. So we are now spending almost a quarter of an hour each time interacting with these AI programs. That's over 800 million people doing that per session. Significant growth from last year. It just tells you how useful it has become. In terms of money spent, just in CapEx alone, so I'm talking about the capital structure to get all the hardware, the power, the grid, and everything else that is helping learning and inference, it's about $500 million. So the number is about just 56% bigger than last year. You will see in coming slides that this is going to be dwarfed massively what's coming ahead. Last but not least, it is 477 terawatt an hour. So that capacity doesn't mean a lot, but it's bigger than a country today. If you take France or Germany, that amount of energy is more than what a single country consumes. And we are just at the beginning. Actually, I would like to tell you that, as Churchill said in one of his very famous slides, sorry, not slides, but speeches, this is the end of the beginning. We have finally entered a new phase of AI, and we'll explore that together. The end of the beginning because a number of things have been consumed and had to be put in place in order for us to reach this level of usage, knowing that there is so much more to come. So I represented these three tiny, graphs here. More billions of users coming, more devices coming, and more usage coming. So let's explore that together, so what it means. So first of all, most of the usage today is very what I call prosumer. So in other words, you and I, even though we are information workers, we are using it for our own needs, with our own desire, often with our own pocket. And companies, governments, institutions haven't yet institutionalized the use of AI for their own needs. Yes, it's happening left and right, but if you just look at the numbers, 800 million ain't the number of enterprise users around the world. And so there is so much more to come, but what is about to come is going to be much harder to come than what has been so far. And you'll see why. Devices. Today, the devices are our phone, our laptops, and but it's coming everywhere. IoT is going to be AI equipped. Your refrigerator is going to be AI equipped. Your oven, whatever you are going to interact with that has connectivity and information to process is going to have AI in it. It is ineluctable. It's my favorite word. And then we've seen last year the coming of agents. I don't know how many of you are using agents. It's there, about like 30-40% of you. Have you heard about agent consoles? Anybody heard about agent consoles? Well, it's coming. So what it means is that now you're going to launch a query to your favorite, GPT, and then behind that you have multiple agents who are going to query different specialized models based on its understanding of your query, of your prompt. It's going to go to this, let's call, Claude for that, Sonnet. It's going to go to Perplexity for this. It's going to go to DeepSeek for that. And then your query is going to run against each of these models. Then an output is going to come. And then the council is going to come together. Those agents will talk to each other and query each other to see which one is the best out of the run prompts that you have just experienced. And then it's going to provide you a synthetic answer of what's the best thing that you can get for the query that you have just issued. I mean, it's incredible what's happening. But what that means is that one single query is now at least four queries without taking into account all the back and forth of what's going on between the agents as they are trying to give you a cohesive and a meaningful answer. So that's the world that we are going into. And if you thought that AI was exponential until today, wait until what's happening in the coming years. We are going exponential in a way that is unprecedented in any technology that we have seen adopted by us over the last 50 years. So we deployed just 2025 alone over 3 million NVIDIA Blackwell GPUs. Not we, but the world. About 11 gigawatt of AI compute power has been put online. We have, at this point in time, in 2026, have used all publicly available data to train frontier models. So in other words, if you are one of the frontier model developers, Mistral, if you are in France, OpenAI if you are in the US, DeepSeek if you are in China, well, there is no more new public data available to train those models. So in other words, we are at the end of the beginning of the learning era. Now, how are we going to learn? How are we going to move forward with it? Well, what happened was, because those models are trained what I call static data, and people did not want to share their data, and so the AI companies said, okay, what we are going to do is that we are going to increase the context window. We are going to increase the number of parameters so that the cognitive performance is even better, sharper than it was before. And it remembers more of what we said 2 days ago, 3 days ago. So with these context windows, which basically is pretty much sending back to the AI everything that you have already sent in the last 7 years, if this is how many years you were using it, so that when the AI is processing that, it knows who you are, what you said, what you asked for. And the problem with that is that your data that you are sending is not improving the model. The model remains as intelligent or as stupid as it was before. And so your new incremental data that you're adding remains ephemeral in its sense. And that ephemerality is about to change. Because there is something coming that engineers, mostly Chinese, are figuring out that they need to reinvent the AI framework that has been giving us this 800 million users so far. The new era that I like to introduce to you, it's called the inference plus era. So I'm the one who added the plus, so there is no such thing. Maybe it will stick. But fundamentally, learning and inference are kind of merging with each other. And that is happening because we are hitting that learning limit and the ephemerality of the use of AI moving forward. And increasing the context window sizes is not a good practice for computing because the memory consumed to process all of that sent back to the AI is really, really taxing the infrastructure. So instead of spending 1 kilowatt, I'm just making this up, but you are spending 20 kilowatt for the same query because you are sending all this context back with huge memory size as time passes on. So things have to change. And I predict that the usage of AI in terms of infrastructure, in terms of cost infrastructure, is going to far, far outpace in what we spent so far in learning infrastructure. The current data center infrastructures that we have today are all tuned, designed for learning. That's where you need 40, 50, 100,000 GPUs in order to have 1 trillion parameters and all this data set to train. And we are reaching what I call the asymptotical limit of that, not only because of the data that we don't have anymore, but because of the infrastructure limits that are really happening in front of our eyes. So if I were to bring it back to something real, training is like climbing Olympus Mons of planet Mars, the highest known mountain in our solar system. It's a one-time learning. You do it, every year. It's tedious. It's painful. I don't know if I just give you an interesting example for those who want to know what's happening behind the scenes. So we work with TII in UAE, and they build a model called Falcon. Falcon is a competitor to Mistral, a competitor to many other models. We call them frontier models. So they use Google as their, GCP training partner. They have roughly 40,000 GPUs that they use at any given time. And that means every second of it, like every second of it. And do you know how many times, how many servers break in the midst of that? About 3 to 5%. So in other words, the servers themselves, for the reasons that they ignore, are going offline while a training is in course. And when that happens, guess what happens? The training stops. Because suddenly you have a portion of memory that you no longer have access to because of the recursive learning mechanisms of generative AI, so you have to start over again. And it is massively frustrating for these frontier model manufacturers to deal with that. So we are also facing some very interesting challenges around the resilience, reliability, and the speed at which you can train these frontier models. Inference, on the other side, is very different. It's something like a river, a rain that never stops. It fertilizes our cognitive behavior, our cognitive needs. And if done correctly, it will shape the way AI is fabricated, is deployed, is used, and is consumed. It suddenly becomes far more personal. It's going to know you by your name, but it's going to know you better than you know yourself, because he's never going to forget what you said before. And it's going to interpret things in a way that you will never have the foresight to do so, because you don't have all this cognitive intelligence that it has. That era is the new inference era we are getting into. But as I said here, it's not the mother's inference that you've been using so far. The model until so far has been very simple, in its systemic way. You have LLMs, which are used on public data training, right? That's what we talked about so far, climbing Olympus Mons every year. There's so much more going on, but I'm simplifying things here. And then fine-tuning and rugging and inference that happens today when you use. But the new model is going to be with your data, with your local data, your contextual learning, prior fine-tuning, and your agents. Suddenly, we are personalizing the world of AI into the world of personal assistant. I don't know how best to say it, but there is going to be the personalization that wasn't possible today, that is literally happening as we speak. And with that, we are getting into next generation of AI, where the LLMs, your data, and your agents are merging. You are now going to interact with something far more complex than a model statically sitting and taking your context window to process your inquiry. So the problem with that is the roads that are today available to get those inference trucks are too narrow, and there aren't enough. The infrastructure has been optimized for learning, but not for inference. And that is a big problem. Today, the gap between today and until 2030, in order to get to the next level of AI, is 230 gigawatts. And trust me, that is a big ask, especially when you know that the electrical grid takes sometimes up to 7 years to connect to that power. So there are a number of data centers permitted, funded, abandoned, 25 last year. The year before, 4. So you have those computers, those NVIDIA cards, sitting at Microsoft warehouses, which cannot be consumed by Microsoft or very similar companies. So it's an interesting situation. Time to market increases. We now have 4 years. It was 2 years before. And as I mentioned, projects are getting canceled. This year, it's going to be probably double what we have seen in 2025. So is this all? Are there other problems? I believe that we are forgetting, beyond infrastructure, what I call the societal geopolitical issues, starting with sovereignty. Where does the data reside? Who controls it? Who owns it? Do I have an alternative? This is today one of the biggest problems that European governments, US and Chinese governments are facing. They are literally fighting over that particular set of issues. Resilience. This is obviously a national security requirement, but when a data center goes down, when Cloudflare goes down, and you are in the midst of doing something important, posing a diagnosis on a cancer because as doctors, this is what you are doing, well, that resilience is a national security requirement. Until today, It was a problem of each company. You deal with your own resilience. Life is changing. And then with the rising cost and the scarcity of infrastructure, you now have to pay 200 euros a month for accessing the best models. And sometimes even more. So what it means is that the best is becoming subject to your financial means. Therefore, elitization of artificial intelligence. Not only there are people who have no means to access it, but now for those who have capability to access it, they won't have means to access the best. So they're going to settle with less. And while others, they're going to go and pay, the 200 euros a month. And last but not least, who's going to pay when the cost explodes? OpenAI is saying we need the advertisement. What's going to happen when Mistral needs 50 euros a month because of the infrastructure issues? So think about it. I told you I'll come back to this number. In 2025, we spent half a trillion dollar in building just AI infrastructure. Over the next 5 years, it's going to be 3 trillion. In other words, you're going to multiply that number by 6. The problem is that this is all going in the wrong direction. We've hit a wall. Today, the growth of AI is no longer possible at the pace that people would like it to be possible because we are facing systemic issues. And those issues are for real. We need a new approach. And I call this the Apollo 13 moment. If you remember the movie Apollo 13, or the expedition to the moon that never landed, came back successfully and saving the life of everyone. What was very characteristic about that mission was that people have used and dealt with the problem that they had with whatever they had, the resources they had. So it was human ingenuity at best. And people brought back these 3 astronauts successfully. And why they did that? Because they had an infrastructure they could use. And it's the same for us. We have a massive amount of infrastructure in terms of power, in terms of grid, that is today unused. And we need to think about using what we have versus what we don't. The right AI infrastructure for me starts with behind-the-meter power, the power that already exists. 5 megawatt here, 1 megawatt there, rather than 100 gigawatt here. Grid that's already connected. Time, fast time to market with model deployment, and with low environmental impact and frugality. It is important that we go after what we already have and take best advantage of that, rather than go and invent something new. And just a few numbers to show you that in Europe, there is a 13 gigawatt gap today in order to fit the demand of AI infrastructure. And behind the meter, look at the numbers of what is available today in Europe alone. That's data, that's power, that's already connected and possible to use, that nobody is going after because it is dispersed, decentralized, distributed. So no grid, no weight, and we need to build the right AI infrastructure. For me, it is taking advantage of the infrastructure problems with what we have and developing geopolitical imperatives, sovereignty, resilience, democratization, and economic efficiency. So thank you very much.